Good morning, class 11. We'll continue with the chapter number 4, that is your motion in a plane. Chapter 4, motion in a plane. Now, in this chapter we had discussed about how the vectors are being added, and for that we had learned about triangular law, triangle law of addition, parallelogram law of addition, and the third one, that is polygon law of addition. Right now we are starting with the multiplication of the vectors. For that multiplication of vectors, we can use two concepts. One which is called as scalar product, or it is also called as dot product, and the second one is called your vector product, or it is also called as cross product. Okay. Talking about scalar product, it's a simple multiplication with a dot. Suppose we are having a vector values, vector A. It is being represented by I plus j plus k with a caps. These are called as vector. Because we are dealing in a plane, that means we are dealing with x-axis, y-axis and z-axis. So hence vector A is equals to I plus j plus k. Now the second vector to which it has to be multiplied, let it be I 2I plus 2j minus 3k. I am taking it and I am explaining you with the help of an example. For the first vector, this is 1I, 1j plus 1k. For second vector, it is vector B, 2I plus 2j minus 3k. Now, how to get this scalar product? Vector A dot vector B is equals to a simple multiplication of this value. I multiply with I, j multiply with j, and k will multiply with k. This is the simple method for scalar product, and for this you can go I, that means the first one, 1 dot 2 into I plus 1 dot 2 into j plus 1 dot minus 3 into k. So these are the three vectors. Hence you will get 1 2s are 2I plus 1 2s are 2j minus 3k. So this is the dot product of vector A and vector B. So this is a simple relation. That means for this condition you only have to multiply I with I, j with j and k with k. If you multiply with any of the other conditions, like if you are multiplying I dot j, it will give you 0, j dot k will give you 0, k dot I will give you 0. So this is a particular condition that you have to follow. But for vector product, it is different. When you take this condition, then you have to take I cross I, it will give you 0, j cross j, it will give you 0, k cross k, it will give you 0. It is just the opposite of scalar product. But for different vectors, like I cross j, you will get k, j cross k, you will get I, k cross I, you will get j. But if you multiply the opposite of it, that means j in cross I, you will get minus k cross j, you will get minus I, and I cross k, you will get minus j. This is a particular vector which you can also learn in your matrix. This is a type of a matrix or a vector multiplication of that same, and that is how you can multiply two vectors. for the special condition, when you talk about, the first condition is that if you take dot product of vector A dot B and it comes to 0, if vector A dot vector B is 0, then that means both the vectors are perpendicular to each other. They are mutually perpendicular. Okay. But second condition, vector A dot vector B, if you get any value of AB, then they are parallel. Okay. The same thing, same funda is different for these two vectors. That is, first condition, if you get vector A cross vector B is equals to 0, then both the vectors are parallel to each other. And second, vector A cross vector B, if you will get the value of AB, then they are mutually perpendicular. So these are the two conditions in which the particle always being taken in consideration, and that is how it is being treated. So I'll be explaining you one of the example for your convenience, and that can be resolved, but I'm going to help you within the second video that how we are using this cross product and vector product. For this we are going to continue in your next video. This is just a general theory for scalar product I dot I, J dot J and K dot K. Three vectors always, because in a plane, motion in a plane or a plane, you always consider all the three axes X, Y and Z. In your next video, I am going to explain you with the help of an example, with the help of two concepts, one with the scalar